Hello, everyone. Thank you all for entering today's presentation. I would like to ask you a question from the beginning of the presentation. Do you know what is the main resource in today's society? Yes, mineral, petroleum, hydroelectricity, and solar energy are all included. And hydroelectricity generates 20% of the electric we use. Today, our topic is hydroelectricity. Hydroelectricity is not a newly developed system for generating power. It has a long history. It has been used over a century in commercial level. For smaller scale, it can be dated back to the ancient Greek, people who use it to power mills or make floors. According to the Environment, a Global Challenge, 1999. In 1878, the world's first hydroelectric system power steam was developed in Northumberland, England by William George Armstrong. And then hydroelectricity develops rapidly worldwide. And in the first half of the 20th century, the USA and Canada lead the way in hydroelectricity engineering. Entering to the 21st century, hydroelectricity continues to develop around the world and playing an important role in electric supplying. More than 16 countries get over half their electric from hydroelectricity, but figuring out how much hydropower will be available in the future and how this highly dependent nation fare is becoming more difficult. Indeed, as the global climate changes, water resources are flowing less or drying up together. Scientists are trying to figure out a new way make the dams can work in a lower water level and more efficiently. So there is still huge developing space for the hydroelectricity engineering. Now, Nat will give us some more specific information for the hydroelectricity electricity.
Thanks, Yilin. So I'm going to talk a little bit about 3 ways that we can actually produce energy using hydroelectricity. Those 3 being conventional, run-of-the-river, and tide. So conventional is the one that you will see most often. It uses a reservoir and a dam. And I'll show you a couple pictures here from the U.S. Geological Survey and U.S. Department of Interior that will explain it a little bit better. So essentially, what happens is this is how the power is actually generated. So water will flow through this turbine, similar to how air flows through, or wind flows through a wind turbine to generate power. It's essentially the exact same concept, except we're using water instead of air. So it'll spin this rod, which spins this rotor. And there's a famous physical law called Faraday's law, which essentially says spinning a magnet inside of a conductor will create a charge, which we can then use to power houses and factories and whatever else. And the faster that you spin that magnet, the more charge that will be created. So in conventional, if you see here, you have your reservoir. The water will flow through the intake, through the penstock. It'll spin that turbine, and then that water will go to the outflow river. The big draw of conventional dams is the fact that we can control this intake. So when you don't need as much power, because it's really hard to store that power to be used later. So when we don't need as much power, you just decrease that intake. But during the day when factories are running and you need more power, you open that back up and you can supply what you need to. So that is the main way that we produce energy with hydroelectricity in the world right now, especially in the United States. But there are a few others. So there's run-of-the-river, which is a similar concept, except that instead of using a dam, they just use a river. They'll dam up parts of the river to make it flow a little bit faster as it's going through the turbine. But the main drawback, and the reason we don't use this very often, is because we can't control the intake as much as we can with the dam. So you end up either not supplying enough power, which is a major issue, or you end up wasting power, which is not good for the ecosystem. It's not good for profits. It's not good for anybody. So that is not used very often. The last is called tide, and this is more of an upcoming method. It's the same thing. You use a turbine, except that they would put them where the tides of the ocean flow in and out. So that natural tide that occurs every day would be the driving factor of the energy. The main issue with that right now, and the reason that it hasn't taken off more, is because tidal ecosystems are usually very sensitive, and they're not sure exactly what they will do to marine life yet there. You can cause all sorts of things, the obvious one being marine life dying from the turbines. And so they're concerned about that. They're still doing research, but in the decades to come, this could very well be a viable energy source to use the tide method. So now I'll pass it to Drew to talk a little bit about the pros and cons of hydroelectricity.
Thanks, Matt. So now that we know a little bit more about the history of hydroelectricity and how it actually works, I'm going to go into a little bit more detail into the pros and cons of the idea. So first off, the greatest pro, whether you believe it or not, the Earth is warming, and we have research that proves that it's because of human activity. And hydroelectricity is a great alternative to this due to the fact that it is renewable. The only fuel used in this is water and gravity. There aren't any fossil fuels or oil or anything that could hurt the environment. Next, it's very reliable. Some of the complaints about solar and wind power, which are also renewable, is that the reliability just isn't quite there. Some days it's not windy, some nights it's not sunny, but there's always river or water flowing in a river, and therefore there's always power available. Next, it's safe. As I mentioned, there aren't any fuels or harmful work conditions for the workers. There aren't any exhausts. It's safe, it's clean, it's smooth, and it's very flexible in how much energy you want to get from it. Now, there are some cons with it. First off, being environmental dangers. As I just mentioned, there aren't any pollutants for the environment, but if done irresponsibly, the damming that it takes in the majority of the hydroelectricity plants anyway, it's capable of changing habitats both in water and in land. Also, it's very expensive. It has a very high initial cost to build, but it's not all bad. After that, there's a very low maintenance cost, and the staff that is required to man a hydroelectric plant is very small, and therefore the cost of the staff is very small from there on out. And lastly, there's only a few limited reservoirs available where we can have these. As Matthew mentioned, there's more than one different kind, but the main kind is the dam type, and they use reservoirs. And if you think about it, in the US, if you tried to think of all the hydroelectric plants here, you could probably come up with Hoover Dam, and that's probably about it. And that's just because there aren't too many great locations for these plants. So in conclusion, we've talked to you quite a bit about hydroelectricity. We talked about the history of hydroelectricity. We talked about how it works, the three different types. And finally, we talked about the pros and cons of hydroelectricity compared to other sources of energy. Hopefully you've learned something, and thanks for watching.